In today's video, we're going to be taking a look at how we can earn interest through either simple interest or compound interest. Interest is basically putting your money into a bank and letting that money grow over time. Okay, so as you let the bank borrow your money, you're saying, hey bank, you can borrow $100 of mine, but in return, I expect some interest. And so you'll probably have seen in your monthly statements that the bank is saying, oh, thank you for your $100. Here is 5 cents that I'm giving you every month in return. Okay. Now you can either earn simple interest, or you can actually have your money grow through compound interest. Now in most cases, you're actually working with compound interest because with the way that the world works, you can always take your money out at any point in time. So the money that grows needs to be in some way broken up into many, many parts. And so the name compound interest has the word compound in it, meaning that, if you put money in and you keep earning interest upon interest, it compounds one upon the other and you accumulate more money that way. So compound interest is actually in your favor. Now the way that the simple interest formula works is through the interest, I, is equal to the principal amount, the amount of money you actually put in, times the rate, times the time. So the longer you put money in, the more you'll accumulate out of it. So when it comes to compound interest, you can be breaking your number of compounds into different amounts. Annually, first of all, means 1 time per year. Monthly means 12 times per year. Semi-annually means 2 times per year. Daily is 365 days per year, not accounting for a leap year here, of course. And quarterly is 4 times per year. So let's take a look at some example problems in which we can calculate its interest. First of all, simple interest basically says that if we want to find the interest, multiply your principal times rate times time. A pretty basic formula there. So if we are investing $10,000 and it's gathering 12%, we write that as a decimal, 0.12. For 1 year, we leave it in for 1 year there. We can calculate that to be 10,000 times 0.12 times 1. And you can see here on the calculator, our interest amount is $1,200. Keep in mind that that's not the only amount you have in the bank though. Remember, you technically have put in $10,000, and at the end of 1 year, you have now earned an additional $1,200. So in your bank, you actually have $11,200. So that's not a bad amount here. Okay. $1,200 only represents the interest. All right, now let's take a look at another case in which we are going to compound our money. Now this is actually how you earn your money through a bank, okay? So we're going to derive the formula here as we compound money. Now keep in mind what compounding means is in a whole year, here we have 1 year, what we're going to do is we're going to take our same value, so 12%, but we are going to break it up into, let's see right here, it says compounded semi-annually. So we're going to break our year up into 2 parts. Okay, so we're going to be paid 2 different times. So the first time we get paid, first of all, what happens is you put your money in the account, you have $10,000, and then what you do is you're going to add that original amount, 10,000 is what you'll always have in the bank, plus, well, you're actually going to earn 12% of the $10,000. And you're going to be doing this for half a year because you're going to get paid at the end of half a year. Okay. Now, if we do a little bit of math here, what we see is that we can actually factor out this 10,000, and what we're left with is 1 plus 0.12 divided by 2, like that. Remember, that's only after half a year. Now what we need to do is take that amount. Here's our amount that we now have at the end of, let's say, June, right? Because we're getting paid at the end of half a year. And then we're going to take that amount, and here's our original amount again, 10,000 times 1 plus 0.12 all over 2. This is kind of like our new principal amount, and multiply this by a new 12%. We're going to earn 12% of that for another half a year, like that. And then doing a little bit of math again, what we're going to see is that we can factor out these amounts. They're the same, which is 10,000 times 1 plus 0.12 over 2. And what we're left with then is a value of 1 whole here. So 1 plus another 0.12 all over 2. And you can see here that the two statements, they're the same amount right here, right? 1 plus 0.12 over 2. So technically this is the same as 10,000 times 1 plus 0.12 over 2 to the second power. That's how much we'll have once we now reach the end of the year. So calculating that, we're going to get 1 plus 0.12 to the, divided by 2. We're going to take that amount and we are going to take that to the second power and then multiply that by 10,000. And now we see that the amount we have at the end of a year compounded semi-annually is $11,236, like that. Okay? All right, how much would we have at the end of 1 year? We found that. What if the account was compounded quarterly? Then what would happen? Okay, so let's examine what happens as we compound it quarterly. So recall, what we're thinking about here is in 1 year, we now break it up into 4 parts. Okay, so we're going to take our $10,000 and in addition to that, let's earn some interest. What's the interest? Well, it's the $10,000 times 12%, but because it's broken up into 4 parts, our first payment is only after a quarter of a year, so times 1/4 of a year. Okay? As we factor out the 10,000, we see now that we have 1 plus 0.12 divided by 4. Okay, so this is going to be after quarter 1. Then we're going to have to take this amount, 10,000 times 1 plus 0.12 over 4. Right, that's our new principal that we're going to start getting paid again. And now we have to earn another amount after that, plus our amount that we have, right? 1 plus 0.12 over 4. And then we have to multiply it by its interest rate being 0.12 for another 1/4 of a year. That's going to finish off our payment right here in the next half, for the first half of the year, right? Now we have 2 payments. Now as we take a look at what's in common with these 2 terms, we can factor that out. 1 plus 0.12 over 4, and then what we're left with then is this whole thing, 1 plus, we already took care of this, 0.12 over 4. Like that. Oh look, this is the exact same thing as saying 10,000 times 1 plus 0.12 over 4 to the second power. Okay, so now that's how much we'll have after half a year. Right there. That's what we'll have right there. Okay? But now what we're going to do is say that that's our new principal, 10,000 times 1 plus 0.12 over 4 to the second power. Right? That's our new principal. And now we add that with our new interest rate, which is taking that amount, 1 plus 0.12 over 4, and then multiplying it by another interest rate of 12% cut into another 1/4 of a year. And that's going to get us our payment at the next cycle, 3/4 of a year. And we see here again, we can factor out the 10,000 plus 1 plus 0.12 over 4. You'll notice that the same kind of procedure kind of repeats itself. So we start to create a formula. I'm not going to finish it all because as you can see, I'm running out of space. But this basically creates our compound interest formula. You'll notice that the 10,000 is always contained within our formula. That's going to be our principal amount. So we call that P times, what you notice we always did was we added 100% plus the new interest rate, which is your rate divided by the number of compounds. Let's call that n. Taken to the, and then you'll notice you always had it to the second. We're going to see it went to the third power or to the fourth power. It's basically the number of compounds, n. And you do that for how many years you're doing this for, to the t power as well. This is going to be our formula for compound interest. Okay?